Never thought so many satellites will be launched. Whatever chips me and you use, the same chips will go to the satellite also. Water on the near equator region, that was Chandrayaan's exclusive finding. Helium-3 will be the fuel of the future. Suppose we get access to that and bring them back, then you will get some rare items. Scientists are not at Cold War.
Hello and welcome to yet another episode of Cosmic Connect. Today I have a very special guest with me. We all know about the Chandrayaan missions. Today I have with me the mission director of Chandrayaan-1 mission, Hegde sir. Thank you so much for joining us, sir, and for taking the time to have this conversation. I'm very excited to be talking to you and to know your story and share that with our audience. So, to begin with, before we get into other things, I would want to know from you that how long has it been? Your association with space industry now goes long, long back. It's been a few decades, I guess, couple of decades.
Yeah. I, I, I did my ME from Indian Institute of Science in Bangalore.
Right.
Immediately after that, I joined ISRO and served there for 36 years. After that, I joined, say, a space startup called Team Indus
Yeah.
and some other company now.
Right.
It's so you can say since 1978 I am into space industry.
Right. When you look back at those 36 years with ISRO, how do you think your journey has been?
To start with, those were the first few years of space industry. Till 1982-83, I spent most of my days and nights in Sriharikota.
Mhm.
So that is how the initial days began. Then later, the space industry picked up and it became interesting more and more. And the climax came in 1998, where I got into the first Chandrayaan-1 mission study. So it was 98, I remember. From then onwards, it was much more interesting. Just earlier to that also was interesting. It was because I was into geostationary satellite handling.
Okay.
So, but 1978 onwards, it was Chandrayaan-1, Chandrayaan-2, Mars mission, all those things till retirement. Now, looking back, I feel satisfied. Looking back, the orbit determination, all those things started just when we started our space voyage, our efforts. So, I feel connected very much because right from the beginning, I was there.
Right.
So my generation was a privileged generation because we saw the beginning and now whatever is happening. So never missed a wonderful moment.
Yes, I think you've seen the entire transition of
True.
ISRO and not just ISRO, but the entire Indian space
International arena also.
international arena because
Yes.
these last 2 decades have been when things have been going up globally.
Yes.
Indian space in
Yeah.
the space industry.
Yes,
globally.
yes, everywhere, everywhere. And initially costs were really prohibitive.
Yes, yes.
Now we have launch costs so many dollars per kg. Never imagined. So we never imagined mobile will be in our hands like
Right,
that.
right.
Never thought so many satellites will be launched in one go, and they will be launched as a per kg basis.
Yeah,
And there will be stations supporting everywhere.
everywhere.
And there is a mushrooming of all the space startups. That is a recent phenomena.
So,
Yes.
sir, what changes majorly have you seen?
Basically, communication.
Right.
So nobody thought from the days of that black handset to a mobile in our pocket and this mobile phone replacing all the computers.
Yeah.
See, this one device has made so many things redundant. And since I was an electronics hardware man also, the marvelous chips which are now there in the market, they integrate just everything. So previously we used to work with NAND gate, NOR gate, so such a very very small elementary things. Now we have so much big systems on silicon.
Right, right.
That is something. So we were thinking about that Moore's law. Every 10 years, number of transistor doubles, all those things, cost reduces. But these things are much beyond that.
Right, right.
So this is the area. One is semiconductor technology, fueled by communication growth. Really, it was a wonderful thing, and cost reduction.
Yeah. Same way, sir, with now that the industry is growing, we have so many companies, so many startups, and space industry is a very expensive industry to be a part of.
Was expensive.
Was, yeah, that's what I was coming to. That do you think that has changed and
Yeah.
is changing going ahead?
Yeah, that is why there are so many startups. So now, long back, what I remember, 98% of the semiconductors were used by military and defense. Just 2% was used in TV
Yes.
and radio. Now, 0.001% is used in space, military, like that. Everywhere else it is used in the commercial things, day-to-day things, everything. Long back we had only military chips,
Yes.
then space industry, space qualified devices, things like that. Suddenly the game changed. Then came a period, then people started using something called COTS, commercial off the shelf.
Okay.
That means whatever chips me and you use, the same chips will go to the satellite also.
Okay.
So there was a battery industry which was dedicated for space, but the lithium ion battery and all battery cells became so cost effective and much better. So space industry was forced to use them by properly screening and packing. Screening and packing because they should be arranged in a better way, and packing because thermally environment should be good, and they should not okay, other constraints, and plus safety, all those things, parallel serial, such things only. So essentially same devices are being used everywhere now. Okay, some small variations called radiation tolerant, such technologies have come. So as a result of this, space has become cheaper and better.
So you mentioned this phrase, the game changed when you were talking about the semiconductor industry right now. But I think the game also changed with Chandrayaan-1 for the Indian space industry, for ISRO, and for moon exploration in some sense. So if you could tell us some things about how do you think Chandrayaan-1 changed the trajectory for India's space programs and also for paved way for moon exploration?
Okay, when Chandrayaan was conceived, at that time our relations with the United States were not very, very good. So we were thinking about using the ground stations other than American,
Right.
and perhaps European also. We were even considering using a large antenna at Saskatoon. All sorts of things were going on. But suddenly relations thawed, and America also got in.
Right.
Then by the time Chandrayaan concept came and study report was ready, and it was presented to a national scientist group in April 2004 or so. That is the study made. Although study started in 98, we gave the report in somewhere in 2002, 2003. Then it was modified. 2004 it was put before in Science Forum in India. Then there was an announcement of opportunity. So this is something done in the international field. They announce the spare capacity so that you can bring your payload. So that time all countries got in.
Okay.
So there were 12 payloads finally when the Chandrayaan flew. So that is the time. So international cooperation was at the peak. Why international committee believed our maiden effort Chandrayaan is a question which I cannot answer. But by the time lot of uh, study material, all the findings were there in the uh, international literature. The moon gravity model also was available by NASA and even Russia. So at that time we were worried whether it is a real one or a better one is there.
Right.
But later now we know, looking on hindsight, it was a correct model only was given. LP100A, I still remember. That once you know the gravitational field and other characteristics, other things were mathematics and other imagination. So Indian, we could do even, although we were doing it for the first time, they were not very bad. Lot of imagination is required, but gravitational field is already known.
Yes.
So you have the basic framework. So as we progressed, we knew that we will do it right. Chandrayaan failed after 10 months, but it did a lot of work. So in international area, people came to know how we can manage the mission, how we can stand alone on our own feet, with little help from other countries. That happened.
Right. And this has been talked about enough now that Chandrayaan-1 and with NASA's instrument and NASA's payload on that, we could manage to find traces of water, ice on the South Pole region. So, what was that feeling like when you were a part of the mission? You were the mission director,
Yeah,
and
there
was
was.
it very clear that that is what we were going out there to look?
Okay, just earlier to that, there was a Clementine mission.
Okay, yeah.
Clementine mission had found a little evidence about all these things, but water on the near equator region, that was Chandrayaan's exclusive finding. It is not really water; it is hydroxyl ions. So now a lot of theory is still coming that Earth geomagnetic tail deposited all these things. See, in Moon there is no atmosphere.
Yes.
So anything goes, just gets lodged onto the surface. So what is predicted by all the people and all the people who work in theorizing the science, what they feel is, see, the sun, our star, ejects a lot of volatiles. See, these solar flares, they are sometimes even earth-sized. They come at near light speeds. But Earth has a magnetic field. So many other planets have magnetic field. They don't get into the surface. But Moon doesn't have any protection. It gets lodged on the Moon's surface. Once it gets lodged on the Moon's surface, it stays there, and there is no wind to blow that. So next every day, Moon gets daylight for 28 20 14 Earth days. So during that time, the solar energy makes these small, okay, all the solar flares, what it lodges is volatiles, means atomic number less than, okay, it is helium and hydrogen, that kind of atomic atoms. So these atoms get excited by the new solar energy and they start jumping, and there is a Brownian motion, and it is statistical in nature. Okay, then now we have something called, very interesting things called uh, cold traps in Moon. That is, Moon's axis is stabilized in the space. Earth and Moon's spin axis is stabilized because their proximity, and the Sun never gets into the polar, or what do you say, the craters of the Moon. Earth is inclined 23.5 degree to the ecliptic, so Sun even illuminates alternately south and north pole. The same thing doesn't happen on Moon. So the craters on the pole, which look north and south, they have never seen Sun for millions of years. These statically dislodged ions, if they get into that place, they never come out. That is called cold trap. Now it is believed that since millions of years, these volatiles would have gone there. Interesting volatiles people are interested in is helium-3. Helium-3 will be the fuel of the future.
Helium-3 is a
Helium fuel of the future for the fusion reaction. See, fission reaction requires some critical mass and all. Fusion, there is no other problem except containing it in a container.
Right.
So some magnetic means if it is brought in, every house can have a fusion generator theoretically.
Theoretically.
So that is the fuel of future. And today we think it is impossible, tomorrow it is a possibility.
Right.
When it happens, this is required. And a small quantity can generate enormous fuel and clean fuel, because product of fusion is not as bad as fissile materials. That is the that is why people are in pursuit with this kind of material.
Okay.
So nearest place which is available, believed to be available in abundance, is moon. That is the reason.
And that is one main reason we are trying to.
Yeah, and everybody wants to get there first.
So, sir, how do you think things will change if we have more access to helium 3 years down the line?
So basically, this pollution will be solved.
Okay.
Then whatever you want to do, perhaps which requires enormous energy, can be attempted. Right now, I cannot think about what is it requires, that kind of thing. Possibly, okay, in a very, very distant future, human kind has to think about seriously migrating from this planet. Right now, it is a distant dream.
Yes.
But people have to put foundation right now.
Yeah.
See, 98 when we started Chandrayaan, Chairman Rangan told, that time I was just not believing his words. He said India is going to be a future superpower in 20s and 30s. We cannot start all the activities now, then. We have to start now. So similar approach has to be done for all the things. We will have to make some small investment. See, now people say India doesn't have water, doesn't have this, doesn't have that. Why space? So unless we put our foot and gain ground, we cannot do that at a later date.
Yes.
So that is where we have to do. Everywhere we will have to put our leg, and believing that we will also be a power to be reckoned with in a not so distant future.
And now, sir, do you think that we are on that path?
Yeah, now because of our demographic dividend, whatever they say, plus all the things, now economics also. I'm not much into economics, but I'm seeing the things are happening.
And sir, in that now, because the space industry is growing, especially after the private reforms came in, we have startups now. So space economy is also something that is being talked about a lot, that is being looked at a lot, and that seems that that will be one major contributor in the economic growth in the future. So if you can share your viewpoints on how the space industry helps in the country's say economic growth, and also socially what are the use cases that the audience might not know so much, that like you said, why are we spending on space, why space is important?
In my opinion, anybody elsewhere in the world would like to see private players in India doing all these things, because they can easily approach them, and it is easy to work with them. Suppose there is an American university wants to put some small payload in a cost-effective manner. Who but India can, private player in India definitely can help. And they cannot go through a space agency sponsored by government, because the terms and condition, red tapeism, and also for maybe justifiable reasons. But private players always are welcome, because they walk some extra mile, do something, and they will be cost effective. And that is where I feel all the people, particularly developed or not developed or academia, will be very happy if a healthy private space industry develops in India. It will be cost effective, and it is easy, and the industry, they will be, all other people will be very happy to work with this generation.
Also, sir, in addition to that, if you could share with the audience, why is it important to explore space, or how space helps us, like people in general, say it?
Okay, now what people are saying is space mining, something which is difficult. So there are so many asteroids, Now people are even tracking interstellar objects. So all these exotic things are coming. So maybe if you develop a cost-effective way of accessing all these things, what is in abundance in Earth crust may not be abundant in some other area, and all these kind of interstellar and interplanetary and particularly Keplerian belt objects and all the once in a while they get thrown into the inner solar system. Suppose we get access to that, if we mine them and bring them back, then you will get some rare items which can withstand enormous heat. Possibly they will help to have a fusion container. We don't know.
Right.
Possibilities are immense.
Yes. And I think that is the nature of
Yeah, what you have seen, you may, and what you can get in a cost-effective manner, that will change the economics.
Sir, now there was so much excitement with Chandrayaan 3 when we finally soft landed on the moon. What were your feelings, and also to see so many people now talking? Like for me, what was very exciting was that so many people who are not really interested in space, they know Chandrayaan 3 is landing, they're excited about it, and everybody was messaging. So I think the reach has also increased.
Yeah, yeah. Because of the media, anticipation is very high, and because it is Chandrayaan 3 and it is a dedicated system, they didn't have a orbiter also this time. So they had a better managed system. The rocket also was a very strong rocket. So confidence was very high, plus media exposure. And having learnt the problem in Chandrayaan 2, it is obvious that we would have do always better.
And how have you seen the Chandrayaan 1, Chandrayaan 2, Chandrayaan 3? Three missions have happened, and in the first one, also, we saw some success because there were so many things that came out of it, specifically the traces of hydroxyl ions. Chandrayaan 2, even though not entirely got successful and the lander did crash, but the orbiter kept going beyond its time and has, provided a lot of information,
Yeah.
helped in Chandrayaan 3, and now you saw. What are how do you see the journey of Chandrayaan?
Chandrayaan 1 had some problems in hardware.
Okay.
Similar hardware flew in Mars mission.
Oh,
So how many years it lasted? It outlived our expectation.
right, right.
So hardware, whatever problems or they have overcome. So Chandrayaan 2 demonstrated that also. But landing was a different ball game. That was rectified in Chandrayaan 3. Then Chandrayaan 1 mission team and Mars study team was the same. We were the same people involved. So we gained so much confidence in Chandrayaan 1. The study report we brought out was much better than European study report on Mars mission because the confidence was there.
There.
So obviously some things which were available in international literature like Mars, this aeronomy what atmospheric model. Just then it was released. That was also accessible to us. That those things were uh, got from NASA and all, which they had put in the what do you say internet domain, public domain. No problem. But all the approach going there, all how to reduce with minimal energy
Energy.
and just with the PSLV, our report was very good. Chandrayaan 2 and Chandrayaan 3 they were supposed to happen because of our launcher development anyway. Mars mission was just with the PSLV, the chairman wanted to find out whether we can have some mission, and we found out that we could have a loosely coupled satellite around Mars. Strictly speaking, it is not a remote sensing
Right.
or any mission, but this gave such a confidence because we were the earlier, India went to Mars earlier than China. So there was a big fight in internet that the Chinese bloggers were very unhappy. All those things we could see. So it was more for psychological reasons. And one of the one of my senior friends was telling, don't worry about the cost and all. It will give a very great feeling to Indian children and all, this mission. At least for that you will have to do this. That's what their opinion was.
Now, sir, when these kind of missions happen, Chandrayaan, Mangalyaan, and all of these missions that happen, a lot of science comes from it as well.
Yeah.
How, like, because I think a lot of data comes, some of it takes time to come into public domain, some of it is then released. How that science can be put to better use, and how can the next generation, the students, try to look into that, read those kind of reports maybe, but how can we put that science to better use?
Okay. About the science interpretation, although American and Russian uh, governments are reasonably at war or Cold War and all, scientists are not at Cold War. They cooperate with each other. The Chandrayaan-2, if we had gone with Russians, the landing site would have been selected uh, in consultation with Americans and Russians.
Right.
That happened
Right.
almost.
Okay.
So there was a cooperation even with the Russians and Americans. So that is the cooperation they have. So Chandrayaan days, every day we were having some anxious moments, and we were getting a lot of confidence and handling the mission. And this time now we are working with a lot of international scientists. They appreciated our effort because this is the way salvaging a mission. They have seen first time Indians doing it. So they had a lot of confidence on us towards the end.
So it's very it's very contradictory, but also I think that, like you said, every day there are anxious moments, but because we are also
Yeah.
proceeding to this confidence also
Yes.
building.
And because of our some planning changes, some things were postponed. They were disappointed. But the alternatives we gave them were far superior than their plans.
Okay.
That also they were very happy. Then one more thing, several things like this that impressed the scientists. So, not the mission managers.
Right.
Mission managers were not there from the JPL and other things. Our mission people, us, were working with the international scientists.
Okay.
So, scientists were impressed by our mission management skills.
So Chandrayaan in a way has also strengthened our international
Yeah, definitely.
trust in.
Yeah, we got to know so many people, and the coverage schemes which we gave them, and they were very happy because there was always an improvement.
Right. And what is that feeling as a mission director when you're in the control room and the countdown has started and the mission is about to launch? What is that feeling?
By the time the Chandrayaan mission started, already some 20 missions were behind us. So it was that way there were no anxious moments because it is the routine launch and early mission operation phase. But only thing this we are going to a different planet. Environment was same. That no, nothing. If there is a human being in this Gaganan, then we would have been worried because we'll have to worry about the so many small things.
Yeah.
Worry about the person's health, what is, all those things. That would have added a new dimension. But handling a routine craft, okay, already we have planned. Unless there is a sudden change, some contingency crops up, then only we'll have to think and respond. Or something is deviating and we know, then we'll have to plan how to contain that. So that was the ongoing process. There's nothing problem.
And I think it's a part of, because with space there is always a little uncertainty.
That way, if you ask, we had really tough time during our first mission when I was handling Apple mission, the so-called Apple,
Yes.
Ariane passenger payload experiment. So that time communication was very bad. We cannot call anybody from Sririkota to here, and nighttime operation, and we are on own. Suppose something goes wrong, everything comes on our head. Suppose everything is successful, nobody bothers.
Yes.
So we were in that situation for 2 months in throughout the night and all. That time we were very much worried than these things.
So now over the years, sir, you have then seen the infrastructure of ISRO growing, the resources growing probably. What has been that shift when it comes to technology?
Computers, see, at that time we had ECL made a computer called TDC-4, TDC-16. We jocularly people used to refer it as totally disappointing computers, TDC. So from that to now, we have desktop PCs,
Yes.
enormous systems, 4-core systems. That is a great thing, and complete plotting software. You can generate anything, and continuously real-time graphics is helping you. That time real-time graphics is unheard of. So many things like that.
And now, sir, ISRO is also planning for Gaganyaan, which has been, it's being talked about
Yes.
so much. It's one of our most ambitious missions
Yes.
because we are taking humans. What are your thoughts on that?
See, the entire craft has to be designed, upgraded for human rating. There is something called human rating. Entire the structure has to be reinforced. Additional redundancy has to be brought in. At every stage, there should be an escape route. But initially, all these things will not happen. So, and entry, re-entry, you will have to prove without human beings, then only human beings will get in. All those things will happen.
Are you confident that this is going?
Yeah, because there is a systematic way of doing it, and nobody will take any risk. It may not be cost effective, but it will work.
It will work. And you talked about Mars, Moon, and we are with Artemis, and that's the plan that eventually we want humans to go back to Moon. Later, we also want humans on Mars. What are your thoughts on that? How far are we from interplanetary travel and settlement?
Mars is almost like Earth. It has a 24 hours day, and daytime, nighttime. That way, human biorhythm will be there.
There. Okay.
Okay, on the moon, there is a problem. 14 hours of Earth day, 14 days of sun
Yes, sun.
day, and very hostile. Temperature will reach up to 100 degrees and above. So, what they have discovered there is the lava tubes. The ancient lava tubes you might have heard, even on Earth it is there. When lava flows underground, it forms a crust outside, and the liquid molten lava flows through inside. Then once the lava flow stops, the lava of whatever is flowing inside, like a liquid through the pipe, ceases to exist, but leaves a hard crust, almost like a pipe. That is a lava tube. Because of the Earth gravity, Earth lava tubes are not as big as lava tubes on Moon. It is believed that lava tubes on Moon can even contain entire Philadelphia city in one tube. So that means you can somehow, if you get into the lava tubes and get into that, it will automatically provides you a radiation shield also. And once you go inside the ground, you can do some kind of air conditioning or whatever, make the atmosphere livable. So that is the way perhaps people are thinking is the way to live on moon. Whereas on Mars, it's a different thing because temperature is slightly colder than Earth. So you can make some mud structures made out of Martian soil, and you can stay there. These are the terrestrial planets. This is where you can do. Venus is impossible. And on the Mercury has got a very interesting things. The day to night transition line moves very slowly. So if you can do something and move along the line, you can stay there, even on Mercury. Possibilities are there. Other than that, though no other planet has got any place to stand because either they are gaseous and you don't have. Whereas the moons of those planets, like Jupiter and Saturn and all, particularly two planets, one is Titan. Titan has got an atmosphere of methane and rain of methane liquid. And there is one more planet of Pluto, which has got a lot of features and geysers out of some other biomass and all those things they're saying. So these are the interesting things, but they are very far off. And what is found was, without gravity, when you travel, the bone mass reduces.
Yes.
And the skeleton becomes weaker and weaker. Some way to manage through providing a artificial gravity or go into deep sleep.
Right.
And wake up later, all these things. Now we cannot imagine what will happen. Maybe there is a way out when it comes to that. This is the feeling I have.
But going to the moon and settling there, having humans there, you think that can happen in a few years now?
Definitely it will happen once we get into the ideal lava tubes and all, provided we find some commercial interest in moon, like helium-3 or some precious minerals, something like that. Unless there is economics driving these things,
Right.
nothing will happen. Just for exploration, for fun, picnic, it won't happen.
Right. And
Maybe space voyage, going there and coming, rich people go there, come and that limited, yeah.
space tourism also, in that sense, you think will start
Yeah,
happening?
it will definitely come. People want to be the first to go here, go there. Like people go to Antarctica, come back, and all those things. Yes.
The workforce, because as the industry is growing, we need workforce. And space is one subject that excites kids, whether we talk about stars or rockets or universe, kids get excited about all of that. But somehow, as we grow up, that gets lost somewhere a little.
The so-called IT job and all some routine jobs are coming to India. Soon it may change.
Right.
So interesting jobs may come up. So once India stands up on its own leg, and worldwide workforce is decreasing, the so-called demographic dividend to India, all those things will happen, and interesting jobs also will come.
Right.
So naturally, the people who are here, who can slightly be being enterprising and learning more, showing interest and curiosity, learning, willingness to learn, can get those jobs. So a lot of space startups start, lot of mentors will be there to mentor.
Right.
So those are experienced people. Under them to work, you will have to work hard. So you will have to really impress them to get information. So that is the win-win situation for both. The person who is teaching you also will be happy, and the person who is learning will get more. So this environment will be automatically, and ecosphere is available. So people who want to do something on their own and come up in life will find these opportunities.
Right. And if somebody wants to get into the technical part of it, then I think the fundamentals of their
Yeah.
well, these need.
See, it will there
Language.
survival of the fittest will come.
Right.
Out of some n number of people,
Right.
out of them some 5 6 people will capture all the skills. Right. And grow up, and they get better and better jobs. So that will happen.
Now, sir, lastly, anything that you want to share with the audience as the industry is advancing and changing?
Yeah, now opportunities are coming across much better than what when I graduated. So you'll have to grab them, you'll have to look for them and show interest, and they are there. If you look at the right direction, you will get them, and I wish them all the success. Find some interesting jobs. So they are always there. Of course, not everybody will get them. That is okay.
But just how the space as a subject is, so is
Yeah, once okay, space once it develops, it develops along with it a lot of other interesting areas.
Right.
You will have to make reaction wheels, star sensors. So all ancillary industries also will develop. So all this.
Multidisciplinary and interconnected.
Yes.
If they're inquisitive, the
Yes,
opportunities.
correct. Yes.
All right. Thank you so much, sir.
Thank
for
you very
your
much.
time. Thank you for sharing all the knowledge and information.
Thank you very much.
Thank you so much for your time.